Okay, so in the first question, they ask you to suggest whether the upper or lower layer contains the organic product. Okay, this is your organic product. They tell you the density is 0.84. It's less dense than water. If it's less dense than water, it will float on top of water and it will be the upper layer. And they tell you that you add sodium hydrogen carbonate. You need to recognize that sodium hydrogen carbonate is a base. Okay, all metal carbonates are bases, and the reason you're adding a base is to neutralize an acid. When you react an acid and a base, you always get salt and water. And when that base is a carbonate base, you also get carbon dioxide. So the gas they ask for is going to be carbon dioxide. The reason you use a carbonate base instead of sodium oxide or sodium hydroxide is because you want that carbon dioxide to be produced because it indicates when the reaction is finished. If you use sodium oxide or sodium hydroxide, you'd still neutralize your acid to get salt and water, but you'd have no indication of when the reaction was finished because you wouldn't see any effervescence. It asks you to suggest the chemical. Okay, we've said you're going to react the base with an acid. The acid in question is hydrochloric acid. What temperature will your product distill? You get that straight from your table. The boiling point is 51 degrees Celsius. That is when it will distill. Then you're asked to calculate the amount in moles. Okay, you're just going to use moles equals mass over formula mass. They tell you that the mass is 3.7 grams. Then you would need to draw out your 2-chloro-2-methyl propane, calculate your molecular formula, and then it's mass divided by molecular formula equals moles. The same at the next one. Okay, you've got 2.22 grams of product. You divide by the formula mass after you've worked that out, and you get your moles. When you're asked for the percentage yield, if you were to write this reaction out as an equation, you would see your ratio between reactant and product is 1:1. Therefore, if you're starting with 0.05 moles, you should be producing 0.05 moles of your product. But you can see you're only producing 0.024 moles. So to get your percentage yield, it's your actual yield, which is 0.024, over your theoretical yield, multiplied by 100, and you get 48%. Question 2 is relatively straightforward from the mark scheme. I'm just going to go through 8b. So they're asking what impurities you might have present when you collect the fraction after distillation. So your common impurities are going to be unreacted starting material. And if we look at what you're starting with 3 different reagents. Of the 3, one of them, sodium bromide, is an ionic compound. And because it's an ionic compound, it's going to have a really high melting point and a high boiling point. That means when you are heating it in the flask, in the reflux flask, okay, it's not going to evaporate and it's not going to then condense and collect as you distillate, okay? It's going to stay in the original reacting flask. Its melting and boiling point is too high for it to evaporate, condense, and collect in your distillate. The other 2, though, they will evaporate, cool, and condense as part of your distillate. And you're also adding water in there. They tell you you're adding water. Water's obviously got a boiling point of 100 degrees Celsius, so it is going to evaporate. They do tell you here what your fraction is boiling at. So you can see that water's boiling point is within that range. And they also tell you that your alcohol's boiling point is within that range. They're going to be your 3 impurities. Question 3 should be straightforward, okay? When you're doing part B, you're answering C, so you're filling the apparatus from the bottom, and the reason you're doing that is to ensure that the condenser is completely full. This part here, B, is just called a receiver. This part for 4 marks, make sure you can answer this question. The marks are the same every single time, so what they want never changes. At the end of this question, just note when you're talking about redistillation, which would be your final point, because they've told you that the boiling point is 116 degrees Celsius, they do want you to use that in your answer. So when you're talking about the redistillation, make sure you mention that you're collecting the fraction at 116 degrees Celsius. Question 4, once you see the mark scheme, that should be straightforward. Question 5. Just need to circle your functional groups. Alcohol, you can call this a haloalkane or be more specific and say chloroalkane, alkene, alcohol, aldehyde, okay? If there's no extended line there, then you can assume you've got a hydrogen, which I've drawn in. That makes it an aldehyde. You don't have to specify if your alcohols are primary or secondary, but it doesn't hurt if you have included that. Question 6, okay? You're asked about the same reaction, but going through 2 different routes. The first one should be 1-step, the second one should be 2-step. In your 1-step reaction, Okay, you're starting off with your alkene. So on the mark scheme, they write this out in structural formula, which is obviously absolutely fine, but you don't have to use structural formula. If you're more comfortable using skeletal and drawing out the molecules, then you can absolutely do that. So I've got my alkene, I'm reacting with water, and I'm forming my alcohol. The conditions would be steam and phosphoric acid. So sulfuric acid is fine there as well. When they ask you for an equation, it's really important that it balances on each side. Okay, so if I had any additional products and they've asked me for an equation, I would need to make sure to include them. When they just ask you for a scheme, so here, for example, I'm reacting my alkene with hydrogen bromide. Okay, we don't use hydrogen bromide as a reagent. Instead, we generate it in the flask by using sodium bromide and sulfuric acid. So when I'm writing my equation or my scheme, I'm going to include hydrogen bromide, but my actual conditions are going to be sodium bromide and sulfuric acid because we use these two reagents to generate this reagent. You could obviously use hydrogen chloride and you don't use sodium chloride there. But I react this and I get my haloalkane. Once I've got my haloalkane, I treat that with sodium hydroxide and I end up with my alcohol. Now, again, here they've just asked me for a scheme. So when I'm doing this part, I don't have to actually include the sodium bromide. If they ask me for an equation, it would be important to make sure my equation was balanced on both sides. But when you're just asked for a scheme, you don't need to include those side products. All they're interested about is the main organic product, which would be your alcohol. You are asked for conditions though, so this part is important. In question 7, okay, same reaction we just had. You're starting off with an alkene. Again, I'm choosing to draw this in my equation, reacting with water, and I'm forming an alcohol. The next part, I'm oxidizing my alcohol to form a ketone. Again, because I'm asked for this as an equation, it's really important that I include my H2O. If you were just asked for a scheme, you wouldn't lose marks for not including H2O, but as an equation, it has to balance. We're just using oxygen in square brackets to represent an oxidizing agent. That gives me 2 oxygens on the left. I need 2 oxygens on the right. Don't forget your H2O. These are the reagents that you would use. 7b isn't on the mark scheme, okay, but it's pretty straightforward. You're starting off with your alcohol. You're dehydrating it to form your alkene. Again, you're asked for the equations. You need to include your H2O here. And then you've got your alkene. You're treating it with hydrogen in the presence of a nickel catalyst, and you're forming your alkane. From your exam questions, just to note that you don't need to do 2C or 2D. We haven't done that yet. 3 should be okay. 4 should be okay. 5 I'm going to do out. Okay, the start of it should be okay. But I'm going to draw the 2 alkenes for you here, okay? So when I'm drawing out these alkenes, I'm asked for my stereoisomer, so I just need to have 1 cis and 1 trans. And if I just draw out, if I just draw out alkene B as normal, if I just draw it out as normal, skeletal, what I'm going to end up drawing is the trans version. So I'm just going to draw that out now. So by drawing it like this, I've drawn the trans version. If I want to change that to the cis version, okay, it's trans because you've got hydrogens on opposite sides of the double bond. If I want to make that cis, I just need to swap that hydrogen with that methyl group, and I'm going to have drawn the cis version. So when I'm drawing this out again, instead of extending my bond up there like I normally would in a zigzag fashion, I'm just going to bring that CH3 group to this side. And that means both of my hydrogens will be on the same side of the double bond, and that will be the cis isomer. Okay. They also ask you for a stereoisomer. Okay. So if we look at the original alcohol and what that would look like, you're treating the alcohol. You're treating the alcohol with an acid, and when you do that, you're dehydrating it. When you're dehydrating it, you're losing water, you're losing OH from one carbon, and then from an adjacent carbon, you're losing a hydrogen. If you lose the hydrogen from this carbon here, then this carbon's losing a bond, this carbon is losing a bond, and the double bond is going to form between these 2 hydrogens, which is what we had in the box below. But if I instead take a hydrogen from this carbon, because this carbon is still adjacent to the carbon with the OH, then it's this carbon and this carbon that are losing a bond, and the double bond is going to form between them. So when you're drawing your isomer, you've lost your OH, you've lost your H, and the double bond is going to be up here instead of here, which is where we had it before. Okay, so this is the next question I wanted to do, 7 part 3. Okay, you've got an alkene and you're trying to get down to a diol. If you get really stuck and you're not sure what you're supposed to do, okay, we only looked at 4 reactions of alkenes. It has to be one of them. And when we looked at those reactions, we used H2, and if we add hydrogen across a double bond, you end up with an alkane. We looked at using like a hydrogen halide, okay, and you'd add HBr across the double bond and you'd end up with a haloalkane. But as well as using a hydrogen halide, you can just use a halogen and you're still going to get the addition across the double bond, but instead of getting a hydrogen and a bromine, you're going to get 2 bromines adding across that double bond. And then the other thing we looked at was adding water across that double bond, and you end up with an alcohol. Now at this point, this might seem like the obvious option because you want to end up with an alcohol. But when you add water across a double bond, you're only adding 1 OH, you're not adding 2. So to get from our starting material to my end product, I need to end up with 2 reactive functional groups, okay? The alcohol, adding water will just give me 1. So if I look at these 4 options, the only one that will add 2 reactive functional groups is by using bromine, okay? When I use bromine, I lose that double bond and I'm adding a bromine to each carbon. Having a bromine on each carbon means each carbon is susceptible to a further reaction, which allows me to put in my diol, okay? I'm also going to do 8, okay? So you're starting off with your starting reagent. You see you've got primary alcohols here on each end, and you're converting those to carboxylic acid, so you're obviously just oxidizing them. But in the middle, you've got an alkene, and then over here, you have got a ketone. So how are you going to get from an alkene to a ketone? Well, anytime we have ever made a ketone, we have gone via an alcohol. So I need my intermediate to be an alcohol. So if I look down at my options, I can see C and D both contain OH groups in them. D has 2 OH groups, C only has 1. I'm only adding 1 extra oxygen here, so my answer is going to be C, okay? From the alkene to an alcohol, from an alcohol to a ketone. We've done questions very similar to 10, so I'm not going to go through, but please pay close attention to the mark scheme. It says on the mark scheme that this question was really badly answered at the time, so pay attention to it. Make sure you're writing your answer from the mark scheme and that you know exactly what to include. The last part of it is just a calculation question, okay? If you were to write out the equation for this reaction, you would see the ratio between starting material and product is 1:1. So if you're starting with 0.150 moles, you should be getting 0.150 moles, but they tell you that you're not, that you're only getting 61.4%. So if I get 61.4% of 0.150, which is 0.0921, okay, that's the number of moles I'm producing, but you're asked for the mass that you're producing. How do you convert moles to mass? You multiply by formula mass, and in this case, the formula mass is 136.9, and that gives you a final answer of 12.6 grams. If you've got any other questions about any of these problems, please just message me and let me know.